Hello, today we're going to learn about different types of functions. We're going to start off with linear functions. Hopefully everybody knows a little bit about linear functions. The general equation we're going to say is y equals ax plus b. Sometimes they say mx plus b, sometimes they say bx plus a. Really, just there's some variable times x plus another variable. The parent function is y equals x, which is the diagonal line crossing through 0, 0. And the transformed equation, y minus y1 times a equals a times x minus x1, we call point slope form. So this is slope intercept, and this is point slope form. And here is our equation. Notice that slope is rise, change in y over change in x. And this point 0b is called our y-intercept. Hopefully you guys have gotten enough of this in 7th, 8th, and 9th grade. Now when we graph this, if our a is positive, so we have a positive slope, that means we're going up, and our b is positive, that means the y-intercept is positive, it will be a line looking like this. If our slope is positive but our y-intercept is negative, our y-intercept has to be down here, but our line is still going up. If b is 0, then that means our y-intercept is 0, so that means we're crossing through our origin. If a is negative, that means we have a downward slope, but if b is positive, y-intercept is positive, but we have a negative slope. Down here we have a negative slope, it's going down, but our y-intercept is also negative. If our a is equal to 0, that just means we have a horizontal line. Our quadratic equations, y equals ax squared plus bx plus c, where a is not equal to 0. Our parent function is y equals x squared. We transform it, we can move it to the right, left, up, and down. And we use this formula, y minus k equals a times x minus h squared. The vertex of that is going to be hk. This is the x, that's the y. And we're going to get a parabola from that. So if I want to make a graph where the a is positive, it would look up like this. It would open up. If a is negative, it's going to open down. Now, a couple of them in vertex equation. Let's say I have y minus 2 is equal to x plus 3 squared. That means the vertex is at 3, negative 2. So I go to the right 3, down 2. And from that point, I draw my parabola. If I have y minus, or y plus 1 equals x minus 2 squared, maybe if I put a negative out in front of that, that would give me a vertex of negative 2, negative 1. I actually did that wrong. This previous one here, hopefully you were shouting at me. I wasn't paying attention. Then when I did it there, I realized that I'm not doing this right. It would be negative 3, positive 2. It should be the opposite of the signs there. So I should have said I go 3 to the left and 2 up, and then draw my parabola. Now over here I move 2 to the right and down 1. And I start there. Since I have a negative, I'm going to come down like this. Now we'll move on to power functions. There's two types of power functions. There's a direct variation, where I have y equals 3x to the 4th. These will look, this one actually will look something like this. An inverse variation will look like this. Now, generally, we don't transform a power function. Once we transform a power function, it gets somewhere else. So pretend like I didn't have this written. So a direct power function, if a is greater than 0 and b is even, it'll look like this. If a is greater than 0 and b is even, or a is less than 0, it'll have the general idea like this. So if I have y equals 3x to the 4th, y equals 5x to the 6th, things like this, it'll look like that. Y equals negative 5x to the 6th will look more like this. If it's odd, then it'll come like that. And when the a is negative, it'll just flip it around. So this would be y equals 5x to the 5th. This one would be y equals negative 3x to the 5th. The inverse power function is when b is less than 0. So when I have 3x to the negative 4th, because it would be 3 over x to the 4th. Now these create a little bit different equation. If a is positive and b is odd, then it'll look like this. However, when a goes less than 0, so if a is negative, it would look similar to that. If a is positive and b is even, it looks like this. If a is negative and b is even, it looks like that. So this would be like y equals 3x to the negative 2. This one would be y equals negative 3x to the negative 2. This one would be y equals 3x to the third power. This one would be y equals 3x to the negative 3x to the third power. Now we move on to exponential functions. The general equation, y equals ab to the x power. The parent function, y equals b to the x. We have a transform function. Verbally, not verbally, we say y varies exponentially with x. And we have some special ones where it's 10 to a power or e to a power. And we've learned about those already, this chapter anyway. So the exponential graphs, if a is positive and b is greater than 1, it'll look like that. That would be like y equals, say, 3 times 2 to the x. Now, if b is between, say if I said 0 and 1, say 0.75 to the x power, instead of it going up, it's going to start high and work its way down. Now, if a is less than 0, if I have negative 3 times 2 to the x, it just flips over the y, or it flips over the x, so it'll look like that. And if it's between, if it's negative and between, so this is negative 3 times 0.75 to the x, it's going to start down here and go towards that axis. Now we move on to logarithmic functions. The general equation is y equals log base c of x. We can transform it, move it up, down, stretch it, move it to the left and to the right. And our special ones are natural log and log base 10. We've already went through this, so this should be review. Log of x is going to be like this. Natural log of x is a little bit more growth. X plus 4, we'll move it to the right 4. Now pretend like this is our x-axis, and so it'll cross through 5. X plus 3, we'll move it to the left 3. And then it'll go through negative 2. So which function is this? Linear What function is this? Exponential, because the x is in the exponents. What function is this? This is a power. It's actually a direct power because it's a positive. What function is this? Logarithmic. What function is this? This one is a quadratic. If I didn't have this plus 7, it would be considered a power. What function is this? This one is none of these. This is a trigonometric. What about this one? This is the same thing as 3x to the negative 2, which makes it an inverse power. This function, it goes down, so that's an exponential. This function will be an inverse power, where the a will be negative and the b will be even. This one here, good example of a logarithmic function. This graph is a parabola, so that's a quadratic function. This one is none of these. This is an absolute value function. One like this comes down, goes back around. This could keep continuing down. That's a power where it's to the third, fifth, seventh power. This one's a nice, easy linear function. All right, so if we were on a Ferris wheel, our height in respect to time, we start up, we go down, we go up, we go down. That would be an example of a trigonometric function. The number of pounds of turkey needed for dinner in respect to the people coming. Well, the more people coming over, each person, you can assume, will eat a certain amount, so that would be a linear function. The time needed to clean a school with respect to the number of janitors working. So if I have 5 janitors working, I'll take less time than if I have 1 janitor working. It will take more time. If I had 2 janitors working, it'll take a little bit less time. But this won't, if I had 10 janitors working, it wouldn't ever go towards 0. So this one would be inverse power. We'll never hit 0. pH of a substance. Now this one's kind of a tricky one. You just kind of have to know pH. Whenever they talk about pH or like the Richter scale, those are all measured in the logarithmic scale. The value of a car depreciates 15% each year. So 15% each year. Each year we're multiplying by 0.85. So that means it's going to be an exponential. It's going to slowly go down. The height of the ball thrown into the air with respect to time. So if we have height, it's going to go up, and it's going to come down. So that's going to be quadratic. All right, hopefully that's enough to get you through the worksheet. Good luck.